Good afternoon and welcome back. Today I'm going to talk about Session 6 and topics for the week. I know at this point you're heavily engrossed with the second responsiveness simulation. Hope all is going well. Quite a bit of a challenge, I know, compared to the first one. Many more options, many more things to think about. Hopefully you're enjoying it, learning a few things along the way. So without further ado, we'll get started here. So short-term scheduling we talked about last time. Really the idea is in the short term, what can you do? What can I do today, tomorrow, over the next week to improve the productivity of my facility? So how do I get things moved more quickly? Faster movement is one of the things we talk about. So when we talk about faster movement, the whole idea is how do I get things to go through more quickly? Think in terms of throughput. In your factory within the simulation, you know, from the time you get the order to when the product goes out the door, with that new contract model, that helps you define how much money you're going to make. So the faster your throughput, the more money you're going to make. And you have to be consistent too, because if you blow it, you know, the money's not there. So the whole idea is that throughput is driving the productivity of your operation, also indirectly driving the happiness of your customer, because if I'm the customer and I order something, getting it a little faster, especially if nothing else, making sure I meet my commitments is really, really important. Additional capacity resulting from faster throughput improves customer service, again through faster delivery, and as we saw with the contract model, you can charge a little more if you're a little bit faster than your competition. Gives you a competitive edge. And then good schedules result in more dependable deliveries. So again, how much variability do you have in your overall process? If you have a lot of variability, then it's harder to make those commitments, you know, because some of the time you'll be on time, but some of the time you won't be. And so you want to make sure that your capacity planning is set up so that you're being productive and you're delivering the product on time every time. So you're narrowing the amount of variability in your process. More flow, more dollars. So scheduling decisions and short-term scheduling. So think of a hospital, for example. You have to schedule which operating rooms are going to be used by what patients, patient admissions. Now, in general, you can't schedule emergency room admissions. That just kind of hits as it hits. But anything elective you could schedule. And then obviously the nurses, security, maintenance staff, all of your variable workforce can be scheduled. And then outpatient treatments. Again, anything on surgical, for example, outpatient surgery, something that is optional, not an emergency, you can do scheduling. You know, it's quite the contrary with an emergency issue. You got to take care of it. So that builds into your scheduling plan. You know, I have to make sure I have a certain amount of capacity for emergency issues. And if all of a sudden I have more emergencies than I had planned and than I had forecast, what am I going to do about it? And in general, what that means is that all outpatient or all optional activity is held off until the emergency is passed. University of Missouri, for example, in a college environment, this is the same for Lake Forest Graduate School of Management. I schedule classrooms, equipment, student and instructor schedules, and then graduate and undergraduate courses. So, you know, how do I balance? How do I make sure I get people through the process? What's my forecast? What's my demand? And how am I going to manage my organization and all my resources based around that plan? Lockheed Martin factory, again, I'm building aircraft typically, or some other military product. I'm building goods, I'm purchasing materials, I'm scheduling workers, maybe I'm scheduling overtime, but I'm balancing everything else. Now, Hard Rock Cafe is kind of an example of service. You know, we often talk about, you know, a lot of the operations management is built around building product and getting material goods in and out of a building. You know, taking the raw goods, building them into the finished good, the finished product, and getting it out the door. Now, with scheduling of services, it's a little different beast. You know, we've talked in the past about restaurant examples, barbershop examples, what have you. Well, with like Hard Rock Cafe, you know, you've got your chef, your waiters, your bartenders, delivery of fresh foods. You know, if I want my food to be fresh, if sales are down, maybe I call my fresh food supplier and say, you know, slow down a little bit. If business is doing well, then I call my suppliers and say, you know, speed up a little bit, give me more product. If I have entertainers, I need to schedule them, and then opening of dining areas. A lot of restaurants will have a structure where they have a primary dining area and maybe secondary rooms. If I rent out those rooms for special functions, that's fine. But a lot of times, if I have excessive demand, more than I had planned for, I will turn my private party rooms, if you will, to simply an extension of the overall restaurant. If I want to do that, that's great. And on top of that, I got to have the food, I got to have the serving staff, I've got to have the chefs and bartenders. So I've got to make sure I've balanced all my resources, the rooms, the people, the food, everything has to be in balance to be effective. And then finally, Delta Airlines, which you can think of generally as a service because, again, they have aircraft, but the aircraft are there to deliver a service. So how do I schedule them? How do I schedule timetables? How do I schedule my flight crews, my catering, my gate staff, my ticketing personnel? And a lot of us have been the victims of scheduling problems, and I've run into it more than once. They sit there and go, well, we've got to get a new crew in here because the current crew's been on duty too long, and according to FAA regulations, they have to be relieved with a new crew. All this builds into the scheduling. And then obviously, where you have a late aircraft, what are you going to do about it? Are you going to cancel the flight? Are you going to fly anyway? And then you get to the destination airport and there's no gate for you. Or all your connecting flights have already left. Or do you sit there and say, nope, I'm going to make sure there's a gate and I'm going to hold off on my connecting flights. And so this chain of events through the service, through the system, is going to, if one flight is late, I'm going to make my subsequent flights late, and everything will just kind of back up. I've seen both, where they cancel flights, where you miss your connecting flight, or where they've held a connecting flight. And a lot of that depends on what's the impact of my overall system, what's my forecast planning model. So for example, I was on a flight one time that was 4 hours late. They actually held 2 of the connecting flights because something like 80% of the passengers on those 2 flights were from the original flight that was late. So it really made sense to wait. Although when we got on the connecting flight, the passengers who weren't on our original flight, they were a bit grumpy and not too happy with us. But it wasn't our decision. It was the decision of the airline. How do things different? Short-term scheduling, manufacturing where I'm building product versus services. Again, building product, I'm scheduling machines, materials, and I can use inventory to smooth out my demand. You saw that with the simulation. If I have a machine that's less productive, I keep the next one down the line busy by building up stock ahead of it. That way, when things vary through my process, my forecast is wrong, my inbound orders differ than what I thought they were going to be, machine breaks down, whatever. If I have inventory built up on the floor, I can smooth out some of those variations. Now in services, though, on the other hand, I can schedule staff, but it's hard to maintain inventory of a service. Like think of a restaurant. Can I serve people before they get there? No. Could I pile up pre-cooked food assuming I guessed the right order? No. Now, if you're McDonald's, you can, have fries ready to go sitting there, and you can, based on your forecast, cook a certain number of fries, or wait till it gets, 1/3 empty or 2/3 empty, and start another batch of fries at that point. But in general, anything that's cooked to customer demand, I can't pre-cook it. I can't prep it. The only exception might be I might get things ready ahead of time. I might get sauces ready ahead of time. I may make a large batch of soup. I'm not going to make soup on demand, for example. And then when I look at machine intensive and labor may be smooth, and labor intensive demand may be variable. So in manufacturing in general, while labor is involved, machines are also a big part of it, doing a large part of the effort required to fulfill the order. On the services side, it's generally mostly labor. It's the opposite model. So again, labor is what's driving your success in the services space. Manufacturing, I'm going to have, I often have union contracts to drive the scheduling of folks. But when services, I may have legal issues again. I put it this way: if I have a restaurant and I'm telling people at the last minute to show up or go home because I'm not doing a good job of forecasting my demand, well, pretty soon my people are going to quit because they're not going to put up with that nonsense. And then manufacturing and services also differ on social or behavioral issues. In a nutshell, in the services space, your employees are the face to the customer. They're out there. The serving staff is face-to-face with the customer, interacting with them. So they are the face of your company. They represent your company. If they're having a bad day, it makes the company look bad, or makes the store look bad, or the restaurant look bad. If they're having a great day, it makes the company look good. So it's very important to have people that are going to have a positive impact and a positive relationship with customers. On the factory, outside of your sales team, in general, most people are behind the wall. It's like the Wizard of Oz, ignore that man behind the curtain. It's the same idea on the factory side. Most of your employees are sitting at a production facility not interacting with customers, and only a handful of people interact with customers. So it's easier to manage the customer relationship in this process. Next topic is just-in-time. Just-in-time, or JIT, is the concept of the ideal inventory situation is no inventory, which basically means I have nothing sitting in process. I have no work in process. I have no finished goods. I don't have a lot of raw material sitting around. Basically, everything shows up just the moment I need it. In other words, if a customer walks in and wants to buy a loaf of bread at the grocery store, at that moment, the fresh bread is delivered, and the bakery delivering the goods, the moment that they need to make the next batch, at that moment, the flour, the butter, the milk, or whatever else they're using in their ingredients just shows up at that moment. You may have seen one of the orange juice, I think it's Orange Growers Association or something. They have a commercial where they show a customer walking into the grocery store and there's an empty slot in the refrigerator where the orange juice should be. And just as that person reaches for the orange juice, a little hand comes out of the refrigerator and hands a carton of orange juice to them. And the implication is that the person behind the refrigerator handing out the orange juice is a orange juice grower, someone who makes sure that the orange juice is fresh or whatever. That's really the idea of just-in-time delivery. So the item's not sitting around on the shelf. It's there the moment that the customer needs it. And that's an ideal situation. But one of the problems with that is, well, there's a lot of problems with that. One of the biggest ones is your forecast has to be dead right. It has to be exact for that to work. The other thing is that your processes feeding the customer the product have to be perfect. Anything goes wrong and that customer delivery is delayed, customer buys something else, doesn't buy your product that day. So the things that we think about in the manufacturing space is the idea of inventory hides all the problems. In this analogy, we have the sailboat up on top and it's smooth sailing. You can see down below here all the little rocks where the boat might run aground. But inventory, that's the green here, inventory is what keeps the boat afloat. It keeps smooth sailing. So if something goes wrong, if I have enough inventory, nobody needs to know. If the truck delivering the orange juice in the previous example breaks down on the way to the store, as long as I've got inventory at the store, customer doesn't know the difference. If there's a bad day in the orange grove and the oranges all freeze and I can't make juice that day, if I have inventory along the way, nobody needs to know. And that's the whole idea. When you have variation, your forecasts are wrong, something unusual or unexpected happens, inventory solves all your problems. Now the problem with that is that inventory costs a lot of money, especially if I'm in a volatile market where all of a sudden, like I'm changing. We used the example in one of the other classes about snowmobiles versus lawnmowers. I have snowmobiles, in the winter, and then lawnmowers in the summer. Well, if I have too many snowmobiles when spring hits, I've got too much inventory. What am I going to do with all of them? I have to sell them at highly discounted rates or store them until next winter. Not what I want to do. So the whole idea here is to show that the boat, that's your smooth sailing, that's your production factory, that's your customer being happy. But the whole idea is that these little bumps represent graphically problems that I might have in my factory. Scrap, for example. Scrap meaning I've got material that's defective. Maybe I've got raw material that came from a supplier that's bad. I may have an assembly that was put together wrong and can't be fixed. I may have finished goods that failed the final test. So I have scrap. I have setup time. The next one is basically, how long does it take me to switch over from one product to another? If I build 4 different products on the same factory line, every time I want to do a setup change, that takes time. My equipment and my people are not being productive when that's going on. The other one here, late deliveries. The product coming from the supplier is late. Using the just-in-time example, if I'm counting on that material being there just the right moment when I need it, that can be a problem. Right next to it, quality problems, and then finally process downtime. Something goes wrong. Now the whole idea here is to lower my inventory is, yeah, I want to have low inventory, but now all of a sudden the boat's running aground. All my problems are appearing, and how do I do this? But the whole idea is, and I've participated in this a number of times, you can purposely reduce your inventory level artificially and sit there and say, okay, I'm going to reduce my inventory level from where everything's smooth sailing. Because a lot of times I really don't understand the impact of all these little anomalies. I don't know that process time is my biggest problem, which it appears to be in this example. So, but by lowering my inventory level purposely, all of a sudden I start seeing these things, and I can see the rock outcroppings. I can see that I've got 4 problems and another one right below the surface, and that process downtime is my #1 problem. When I identify this, what we would often do then is return the inventory levels to their previous position. But in the meantime, sorry about that, bump the mouse, but work on process downtime. Lower this peak. And then I know quality problems are my #2 issue. I can do that. So then I reduce my inventory level again, and these bumps are not in my way. So now I can focus on others. And maybe new ones are going to crop up because of something I've changed in my process. But here the whole idea is, if I don't want to punish my customer for the evils of my factory, for lack of a better term. So if things aren't going well, I don't want to punish the customer because the customer is going to go somewhere else. So I want to understand my process. Ideally, I don't want to cause the ship to run aground, but I need to analyze my manufacturing flow, my throughput, and understand where these problems are. By lowering the inventory level, I can identify these and then address them. And that's really the goal of this. So I want to eliminate inventories rather than optimize them. And so this is, you might say, a blind approach. In other words, I'm going to go reducing inventory whether that's the right thing to do or not. So the whole idea is that I want to do just in time. Just in time may be too aggressive. Maybe I'm going to do same day. So in other words, I'm only going to bring to the floor that which I need for that day. And this was not an uncommon approach. One of the factories I worked with, we would bring the night shift would bring all the material down and queue it up for the day shift. And at the end of we ran 2 shifts and then ran all of our inventory activities at night. So we would run first shift during the day, second shift during the evening, and then after midnight the inventory folks would show up. Any inventory left on the floor would be put back in the warehouse, and then we would look at the orders required for the following day and go through the process again. And the whole idea was we would clear the floor every time, and then some of the outcomes, smaller lots are ordered. Is that a good thing or a bad thing? Depends. If you effectively have reduced your setup times and your lead times, this can be a good thing. I've got less product out on the floor. One of the biggest advantages of this is if I have a volatile situation where all of a sudden the order requirements change. Sales calls up and says, hey, forget it, we don't need 100 of product A, we need 100 of product B. Well, if I've got 500 of product A on the floor, that's a problem. If I have 20 on the floor, well, then I can just put away 20 for the next day. So I haven't wasted a lot of productive time building a lot of product that I really don't need. The other situation where that happens is if I have a product defect. What happens if I have, let's say, 1,000 products on the floor, and the first one hits test and they find a defect, and they check the second one and they realize that a mistake had been made, and all 1,000 are bad. Now I have to rework, or worst case, scrap 1,000 items. Not a good idea. If I only have like 10 or 20 on the floor, obviously a much easier situation to manage. So I want to reduce lot sizes. And we know from the inventory on the simulation that you have this sawtooth pattern. And those of you who are math majors, or you remember your geometry, you've got a sawtooth pattern. And we saw this. Your inventory is used up, used up, used up. You hit a certain point, you order more material, and basically the new material comes in, it's used up, used up. Now this assumes that you've got a perfectly linear demand, it's the same. And we know that in real world, as in the simulation, that's not always true. But in general, it follows a pattern similar to this. So you can sit there and say, okay, I want to cut this down the middle because it's a triangle, so the area under this line is my average inventory. And it's not hard to prove if you look just graphically. This triangle fits into here, this triangle fits into here. So I can draw a straight line across here. When my order quantity, when this number, this peak is 200, the average is going to be around 100. And that's just mathematical. So the whole idea is I can sit there and go, if I'm ordering 200 every time, my inventory average, my carrying costs, if you will, with inventory are going to be associated with 100 items. So if I want to reduce that, I simply have to reduce this line. And how do I do that? I lower the peak. So I've created a second line here, or second graph, with a peak that is roughly half the size. So when my average order size is 100, I'm going up to this line each time, so my average inventory is only 50. So I've cut my average inventory in half. Is that a good thing or not? Well, we know that by doing that, I can reduce my inventory, and thus the dollars associated with storing all that inventory. But it depends. What's my setup each time? What's the cost of handling an order? What's the risk? If I have a lot of risk, I might want bigger orders because I want to have the certainty that I've got inventory to work on. But if I've got a fairly good vendor and the quality's been pretty good and there's no risk of getting the material in, like through snowstorms or floods or what have you, I can live with a much smaller inventory because I can live a little closer because I have less variability in my process feeding me in. So, setup times. I have setup time in just about every process. If I have a major product line, so one of the biggest examples I can think of is the auto industry. If I sit down and say once a year I'm going to switch from the 2017 model to the 2018 model, in the auto industry that's a big deal. Typically that takes them on the order of 2 to 3 months to do that, unless it's a fairly minor change. And you've seen that. You can tell a minor change when the 2018 car looks just like the 2017 car, except for, they change the color of the seats or something superficial. But if it's a major change where it's a major redesign, the body style is different, the engines are different, the frame is different, that's a major change, and that's going to take several months to switch over. So if I do this on a smaller scale in the factory, I have a similar situation. So in an average factory, I might have a 90-minute cutover. So if I want to build 4 different products during a day, if it takes me 90 minutes to cut over each time, well, that's quite a bit of my productive day. So I can't afford to switch over very often if I have a 90-minute cutover time. But if I can reduce that time so that I'm down in the less than an hour or less than a half hour, then I have a whole lot more flexibility. If all of a sudden I decide that product A is no longer needed and product B is, switching over is no big deal. If it's 90 minutes, well, it's a big deal. I've just lost an hour and a half of productive time. So the whole idea here is to take setup time and optimize it. And the steps we typically take is we start with the original setup time. We break that down into various steps. In other words, are there things that we can do ahead of time? So one of the factories I worked with, we had a setup cart. And what that meant was if we were going from one setup to another, all the parts, the tools, the instructions, maybe the new software for the machine, everything's sitting there on a cart ready to go. So the moment you turn off the machine, all the parts, all the tools, all the instructions, all the software, everything you need to convert from product A to product B is sitting right there, so the technician can be very effective moving from one product to the next. Moving material closer to improve material handling. Again, do I have the product I need? Is the material ready to go? Because a lot of times we have delays. The machine's been converted over, but the material that is going to be used by that machine to build the product isn't available yet. So we move the product closer. Standardize and improve tooling. What does that mean? I have tooling that's used on product A and has to be pulled out of the machine and new tooling put in for product B. If I can standardize on the machinery or the tooling to do both products, then it's one step I don't have to do. An example of this might be CNC operations, where it's a computer-driven process. So I don't have to change the tools. I just quickly push a button and I'm going from program A to program B, and the moment I hit go, product B is being made. So there's no setup. There's no switching things over. And then one-touch systems to do things. Again, training operators and standardizing work procedures. So again, by studying the process, the steps that I take going from product A to product B, and streamlining things, figuring out what the bottlenecks are, tip of the hat to the goal, I can go in and I can reduce my cycle time during setup. One of the things that we've seen is scheduling system for lean just in time. They have what's called a Kanban or a pull system. Maybe some of you worked on one of these. Kanban or a pull system, the idea is that a group or a work cell, like if you think about the simulation, I have 3 different stations. People working in that station wouldn't do anything until the next station down the pipeline says, hey, I need one of those. Then they would start working. And typically it's not as simple as that. Typically it would be a situation where, like station 3 in our simulation example, when they're down to 1 part left in the queue, they send a message to station 2 saying, hey, I need another one. And station 2 reacts. And then when station 2 is down to 1 part in the queue, depending on which part it is, they go back to station 1 or station 3 and say, hey, give me another one. But the whole idea is the stations don't do anything. You've got machine capacity, you've got product, you've got people sitting there doing nothing, waiting for the next person or a process down the line saying, send me more work. And it's an interesting approach, an interesting way to do it. And I've got a video here to show you how this works.
A simple and brief demonstration of a Kanban pull system presented by the Mestec Corporation. This Kanban demo shows how the pull system works by replenishing the blank spaces of parts that were used. Parts are pulled from the shelves to assemble and package a product to be shipped. Using the parts leaves an empty space that is a signal to the rest of the shop to replenish what has been used. First, the color machine produces another green part, which leaves an empty space to indicate to the press upstream to restock that part. The assembly of the unit leaves a blank space to signal the shape machine to produce another blue cylinder. The cardboard box also needs to be replaced. The box maker pulled the last box from that pile, revealing a card which was sent back to purchasing, informing them to order more cardboard. The whole system is driven by visual signals to restock only what has been consumed.
So again, the concept there was that everything that you saw, the idea was that everything is built station by station on demand. So the customer need feeds the assembly area, the assembly runs out of a component, that feeds the other production areas, and on back ultimately to the material providers. So it's a simple process. Again, though, as you can see in this example, there wasn't just one item, there were a few items on the shelf at any time. So there was a little bit of buffer stock. You notice there was a few extra boxes on the floor before we ordered new ones. So the whole idea there was not the ultimate, if you will, but probably a little more realistic because nothing runs perfectly, and so you want to have a little bit of inventory on hand. The next subject is lean. Again, the whole idea of lean being, are you doing only what's value added? So many of you, I'm sure, have participated in lean activities. I have a number of different organizations. It's very, very common and very useful, especially in some larger organizations or organizations that have been around for a while. So every so often you need to step back and go, well, gee, is everything we're doing really what we need to be doing? Have we optimized the process? Are we just doing things that add value to the product? And very simply, the easiest way to look at that is to say, look, if I didn't do this, would it diminish the quality of the product? Or if I do something, is the customer likely to pay more because that one process or that one step enhanced the quality of the overall product? So the idea is to accelerate speed and reduce cost by removing waste. In other words, if it doesn't need to be done, don't do it. And again, the classic example, if you've seen the movie Office Space, the TPS report. Nobody knows why they do it. It takes time out of everyone's day. Nobody knows why, and one individual quits doing it, and nothing matters. It doesn't change a thing. So this is an example of something as a process that is waste. It doesn't need to be there. So when I look at this, it's like the goal is to create an environment, or a cultural environment, so to change the culture of the organization. You don't want people sitting there and saying, well, why do you do this? Well, because we've always done that. That's not the idea. The idea is like, well, why do we do this? Well, let's understand why we do it, and let's change it if we need to. So the whole idea there is that I'm going to continually improve productivity and efficiency. So I'm going to have less material, less capital, less energy, less waste per unit of production. And one of the key parts of this is that it's an employee-involved program. In other words, everyone does it. You know, it's not the boss coming in from somewhere else or the engineer showing up on the floor saying, hey, you guys need to do this differently. It's one of these things where you get everybody, the production people together and say, folks, you know, what can we do to make this better? And look for ideas and suggestions. And you'd be amazed at the high quality suggestions that you're going to get. So again, the whole idea, the value stream. How do I minimize things that don't add value to the product? How do I get the flow simplified? How do I do the right handoffs? Do I do them at the right time? Can I do things in parallel instead of always in series? And the idea of batch versus flow. Batch meaning I have 100 units. I do step 1 to all 100, then I do step 2 to all 100, then I do step 3 to all 100. And the problem is, like I said before, if I get to step 10 and suddenly realize there's a problem, I've got an awful lot of product in the pipeline. Where the flow concept is, think of like a pipeline. You know, the product goes in and just continues. It's a continuous flow. So as soon as the first item is done in station A, it gets handed off to station B. And as soon as that's done, it's handed off to station C. So you keep pushing the product through. The idea is that you have a pull process. Again, that was the example in the video where the end of the line pulls from the previous steps upstream. And then in perfection, you have no handoffs. Everything is just continuous. And that's oftentimes a goal and not directly achievable, but that is the goal. So again, waste is something that adds cost, that doesn't add value. If you do something less and the customer doesn't care, then you got to ask yourself, why am I doing it? So there are a lot of different kinds of waste out there. Waiting, inventory, transportation, motion. Overproduction. So inventory is obvious. I have too much inventory. Overproduction. I've got more product coming out the facility than I need. I've seen cases where finished goods inventory sits around in a warehouse and no one ever looks back and says, gee, did we make too many of these? Overprocessing is the idea of the customer ordered something simple and you give them gold-plated everything. Well, it's going to make the customer happy potentially, but are they really going to pay for it? If that additional capacity doesn't interest them and drives the cost up, they may not come back to you. So obviously waiting on parts on the left, defects, rework, transportation, and motion are all obvious. So moving things around for the sake of moving around where it doesn't add any value is a huge waste. But I want to really draw your attention to the lower right, intellect. This is the idea where I waste the power of people. What does that mean? I disregard their thoughts. I disregard their capabilities, their suggestions, their ideas. I have someone who comes up with a new process methodology and I ignore them. And I've seen this more often than not. You get into an organization. I've seen cases with managers in large organizations where I've got a job opening. Am I going to hire a technician or am I going to hire an engineer? Well, if nobody else cares, I'm going to hire an engineer because I want to have better talent if I can. But if I really only need a technician, then I'm wasting the engineer's time. I'm wasting their intellect. If anything, it's going to frustrate them. Plus, I may have not given an opportunity to someone who deserves it, who could do the job just fine, and maybe it's even a challenge and a growth opportunity for them. So, again, I think this is something that's near and dear to my heart that way. So, in summary, we've talked somewhat briefly about short-term scheduling, just-in-time, TPS, and lean operations. So I wish you well with your continued work on the simulation, and see you all again next week.